Proving triangles congruent using transformation. To start things off, we need to learn some key terms. Rigid motion is when you have two shapes that have congruent corresponding sides and congruent corresponding angles. Shapes A and B are congruent because of rigid motion. This is because of corresponding sides and angles are congruent. But shapes C and D are not congruent because of rigid motion. This is because corresponding sides of the shape are not congruent. Now, on the right, there is a triangle. Our job right now is to reflect this triangle across the y-axis. This is the y-axis. Now, to do a reflection correctly, we need to find out what we are reflecting across, which is the y-axis. Then you count how far away each vertex is from that line. Now that we know how far away each point is from the line, we can then preserve the distance each one is from the line, and then go that same direction on the other side of the line. We take the vertices and create a brand new triangle. To prove our triangle is congruent, we use rigid motion. Now we know that since corresponding sides and corresponding angles are congruent, the triangles are congruent by rigid motion. And then if you want to know the formula, you just multiply each x value by -1, and then that's how you reflect across the y-axis. And as a note, this does not work for all situations, just this one. We are going to learn about rotation. To the right, we see our triangle and its three vertices, marked with their location on the coordinate plane. The easiest way to rotate a triangle is to multiply the x and y values with 1 or -1 depending on the rotation. If we have all rotations going counterclockwise, if we're going 90 degrees, you multiply the x value by 1 and the y value by -1. For 180, you multiply both the x and y values by -1. And for 270, x by -1 and y by 1. So, we are going to rotate our triangle 180 degrees around the origin. So we multiply each x and y coordinate by -1. So our new points are 1, -1, 3, -1, and 3, -1. When we place these points, we rotate around the origin 180 degrees. We have rotated 180 degrees. Let's make sure our triangles are congruent using rigid motion. And they are. All corresponding sides and corresponding angles are congruent. And as you can see our new formula, you can just, instead of starting out with x and y, you can go to -x and -y to rotate 180 degrees around the origin. Finally, we are going to learn about translation, which is also known as moving each point. Here we have two triangles, and we need to find out using rigid motion if they are both congruent. Then, we find out how much the x value changes in the translation, and then the y value. And x changes by a factor of 5, and y changes by a factor of -3. We also know that since each part can't have a different change in x or y value, because we only moved the shape, we can conclude with this formula: x, y to x plus 5, y minus 3. And this still works only with this example. Now just for the heck of it, let's get a little fancy. We have two triangles that are congruent because of rigid motion, but the question is, how did it get to its current location? First, we get our coordinates. As you can see, our coordinates are now on there, and now that we have our coordinates, what should we do first? A. Rotate counterclockwise around the origin 90 degrees. B. Dilate the triangle by 1/3. Or C. Translate so x, y becomes x plus 1, y minus 3. Answer A is the best choice to get things done faster, so we are going to rotate the triangle 90 degrees around the origin. So, if we follow our rotate 90 degrees rule, we multiply each y value by -1. Now that our rotation is done, shown by the dotted line triangle, what are we going to do next? Well, how are we going to reflect it now? Because we got to get it flipped around for the shown by the new triangle. So, are we going to flip it over the x-axis, the y-axis, the z-axis, or negative 21? Answer B, the y-axis, is the best. So now we can measure out our points and reflect it. Now, we reflected it off the y-axis correctly, so now we are going to have to translate the triangle to its correct position. Which one of these below is the correct way? X, y, 2, x minus 2, y plus 2, B, y plus 2, x minus 2, C, x plus 2, y plus 2, or D, 2x, 2y. Answer C is our best choice, moving up 2 and then over 2. And now we know how our new triangle moved to its new location. A formula for this, not sure if it's good or not, but x, y to x, negative y, which then goes to negative x, negative y, which then goes to x plus 2, y plus 2. And this does not work for all cases. In review, we learned how to prove triangles congruent using rigid motion, which means that corresponding angles and corresponding sides all need to be congruent. To reflect a shape, you measure out how far each vertex is from the line you're reflecting across, and to measure the same distance out on the other side of the line. To rotate a shape, to multiply the x and y values to rotate counterclockwise 90, 180, and 270 degrees, and how to write an equation and how to translate a shape. I hope you enjoyed watching this video and it was very helpful for you. The end.